Good morning, everyone. Today I am going to present an important topic in dairy technology called Organization of Milk Collection Routes. This topic explains how milk is systematically collected from different villages and transported efficiently to dairy processing plants. It is part of our undergraduate dairy technology course. To begin with, let us understand the introduction to milk collection routes. Here we can see a typical route structure. Milk starts from village-level producers. It is brought to a village collection point. From there, it is transported to a chilling center. After chilling, milk moves to the processing plant. Milk collection routes act as a farm-to-plant link. They connect scattered producers to the dairy plant through organized logistics. Organized pickup ensures that every registered farmer's milk is collected regularly. Strategic route planning also helps in quality and cost control by minimizing spoilage time and transportation expenses. Let us understand the meaning and purpose of a milk collection route. A milk collection route is a systematic and planned path followed by transport vehicles to gather milk from multiple producers and deliver it to a central processing plant. The first purpose is to define fixed routes. This ensures consistent pickup times and prevents missed collections. The second purpose is to ensure quality. Minimizing time between milking and chilling prevents bacterial growth. The third purpose is efficient logistics. Proper planning reduces transport cost and optimizes vehicle capacity. Next, let us examine the components of a milk collection route. The first component is dairy producers. These are individual farmers or village units where milk production begins. The second component is collection centers. These act as aggregation points for weighing, testing, and preliminary storage of milk. Transportation forms the connecting link. Milk is moved through cans or road tankers to the main plant. The final stage is chilling and processing. Milk is cooled to 4 degrees Celsius or processed for retail distribution. Moving further, let us look at the village-level milk collection system. The village cooperative society is the first point of contact. Farmers organize themselves under cooperative structures to manage milk aggregation collectively. Milk is usually collected twice daily, in the morning and evening, to match milking schedules and prevent spoilage. Basic quality testing is conducted immediately. Organoleptic tests, fat content, and SNF are checked to determine acceptance and price. Collection centers perform several important functions. The first function is weighing and testing. Milk quantity and quality parameters such as fat and SNF are measured immediately upon receipt. The second function is record keeping and payment. Digital records ensure transparent and timely payments to farmers. The third function is cooling and dispatch. Milk is chilled to preserve freshness and dispatched to the processing plant without delay. Efficient route planning and scheduling are essential. Distance and time must be minimized. Milk should reach chilling centers within 3 to 4 hours after milking. Load capacity must be optimized. Vehicle type should match milk volume to prevent underutilization or overloading. The first in, last out principle is followed. Milk collected first should be unloaded last to balance temperature exposure. Let us look at the transportation flow from farm to plant. Step 1 is the dairy farm. Milk is filtered and temporarily stored. Step 2 is village collection center. Milk is weighed, sampled, and aggregated. Step 3 is transportation. Milk is moved through insulated cans or road tankers. Step 4 is chilling center. Milk is rapidly cooled to 4 degrees Celsius to arrest bacterial growth. Step 5 is the milk processing plant. Milk is pasteurized, packaged, and product manufacturing. Timely milk collection is extremely important. Milk has a natural germicidal period of about 3 to 4 hours. If chilling is delayed, bacterial growth increases rapidly. At room temperature, bacteria can double every 20 minutes. Maintaining the cold chain below 4 degrees Celsius inhibits bacterial enzymes. Once the cold chain is broken, milk quality cannot be restored. There are several challenges in route organization. Milk production is scattered. Small quantities are produced by thousands of farmers across wide rural areas. Long distances increase travel time and fuel costs. Quality deterioration is a major risk in tropical climates. Strict timeline adherence is necessary. Seasonal variations between flush and lean seasons affect vehicle capacity planning and route efficiency. This slide provides a visual summary of the complete system. Milk flows from producers to village centers. From there, it moves through optimized logistics routes. Milk is chilled to 4 degrees Celsius, which is considered the safe temperature zone. Finally, milk reaches the dairy plant for processing and distribution. Finally, I conclude my presentation. Organization of milk collection routes is essential for maintaining milk quality, reducing spoilage, and ensuring operational efficiency. Thank you for listening.